Hello, can everyone hear me? Alright, I think we can get started. Please let me know if you can't hear me in the chat. If you can, let's get started. Or could you let me know if you guys can hear me? Okay, great. Thank you for letting me know. Let's get started. So click on the GitHub link in the description. I'll take you to this GitHub repo and go scroll down. If you want to run this locally, I'd recommend that, but if you don't have a Docker installed, you could also run it on Codespaces. Go ahead and click on this Open in GitHub Codespaces button. What this is going to do is that it's going to clone this repository into your account and start a Codespaces, which is basically GitHub's online development system. So go ahead and do that. It'll take a few minutes to start. Once that's started, just copy paste this command, and if you're running it locally, you just need to copy paste this where you'll be kind of cloning this repo and then starting Docker Compose. So please go ahead and do that, and in the meantime, let's get started. And please let me know in the chat if you get stuck with any setup process. So welcome to the workshop. The main objective of this workshop is to show you how to design fact and dimension pipelines and why those are kind of the most critical parts of any data system. Throughout this course, you will have a couple of exercises. So as we go through them, you will see about 3 exercises. Do not use LLMs to answer those for you, and that's because these exercises are designed to test your understanding. While LLMs can help you understand, get you to the answer, it'll not help you build that intuition, and over time, you stack these intuitions on top of each other, and that's how you kind of build your skill set. So I recommend, at least for this workshop, don't use LLMs to just answer your question. Spend time thinking about it, with your brain. Yeah, and we have Spark and Iceberg running. Spark was mostly what we are going to be using, but you don't need to be an expert with Spark. It'll just be very simple Spark transformations. We'll mostly use Spark SQL as well. Okay, so let's get started. So if you have your Dockers up, open localhost 8888, or if you're running it on Codespaces, click on ports in the Codespaces VS Code terminal and click on this 8888 and click on this globe icon. That should open up the notebook for you. In the notebooks, we have 2 folders, notebooks and notebooks with solutions. Use the notebooks for this workshop, but know that all solutions are fully available in the notebook with solution section. So if you want to look at the solutions, you can go there as well. So open the workshop and let's set it up. Hey Levi, so setup is pretty straightforward. We are just starting a local Spark session. It takes a few minutes, and what this does is it'll create a dataset called TPCH, which is basically bicycle parts warehouse, and this is the dataset that's used for a lot of benchmarking. And this function will create 0.01 GB, and you can change this if you need to have 5 GB or 10 GB, but 0.1 is enough for this workshop. And then this part will create them as tables in Spark. So in your own time, you can look at these scripts, which is basically run DDL and generate data, but for this workshop, you don't need to worry too much about that. So let's give it a few minutes. It takes about a minute or so, and throughout this course, you could just say spark.sql and write any SQL queries. So here's an example where we are, just looking at the tables available. If you get py4j.client server error, ignore that for now. It's something I'm working on. It might show up, but you'll still end up getting the answers. I'll stay on for Q&A at the end. So for this workshop, we'll go through the facts and dimensions, but during the end Q&A session, you can ask me any questions about data or data industry in general. I'll pause here for a minute. Do you have any questions so far? Is anyone having difficulty setting up your infrastructure? Please let me know in the chat. Yeah, sure. You don't have to try it, but I would recommend just for the exercises at least kind of trying to draw out the solutions if you can, because that will just help you understand. Code is not that difficult in this course. It's more about understanding different scenarios, so it's fine if you don't get it running. Okay, so I think we can go ahead and get started. So the first takeaway I want you to take from this course is facts and dimensions are your most critical assets. So let's see what that means. Let's look at this diagram. Different companies have different names for this type of data flow, but typically the idea is, you get some data from multiple sources. You see in the leftmost section, you got user browser, you got database, you got external vendors. They will drop the data in some sort of data store. It might be S3, it might be SFTP, it might be FTP, it might be flat files, whatever it might be. And then you have something called bronze layer or raw layer. Different companies have different names, but the idea is you do some sort of data type conversions and column renaming to have all the columns have kind of conform to a convention. So that's the layer one. Then you do layer two, where you create fact and dimension tables. Some companies have in-mon style, but that's very, very rare. Most of the companies, they just do facts and dimensions. And then finally, you aggregate it to something called marts, which is basically you join facts and dimensions, group by, and make it available for use by analysts, dashboards, AI agents. So if you look at this kind of pipeline, if you will, the first part, ingestion part, you have a lot of SaaS companies here. Because this part is so mechanical, it can be automated for the most part. So you got like Fivetran, the popular one. You got Estuary, the new and upcoming one. You had systems like DLT, which is a Python module that helps you do this. You have systems like CDC with the BCM. They all focus on this first part of the pipeline, and it's pretty much automated. Of course, there are going to be issues, but for the most cases, these are more standard automated systems. So a lot of companies do this for you. You also have Databricks ingest, and different cloud providers have their own version as well. Excuse me. The facts and dimensions will come later. Once we have the facts and dimension, you create these summary tables. Some companies have specific teams for this, like analysts. You have semantic layers, you have metrics. So for example, these might be created, this goal layer might be created in Looker, something called LookML, or DAX as well. So the idea here is you define metrics, you define dimensions, and then you can drag and drop and create the report that you need. Now when we come to the middle layer, that's where the core of our value lies. That's where we create facts and dimensions. So we are creating new data, or not new data, we are reshaping data for analytics. That's the key area we have to concentrate on. If your facts and dimensions are correct, complete, fast, everything else will be easy. If you make a mistake here, it's going to be painful, because you'll have to debug the goal layer, you'll have to debug the fact and dimension layer, and then you'll have to trace back to the source layer. It is going to be painful. So if there's one thing you could do, if you're going into a new company, everything's a mess, fix the facts and dimension, make sure it's on time, make sure it's correct, make sure the data is complete, meaning data is ready to use. So when you create a data set, it should be complete, meaning if you're creating data for yesterday, make sure all the data from yesterday is available. So that's kind of the primary takeaway for why facts and dimensions are kind of the most critical part of your data pipeline. And if you have the chance, make sure facts and dimensions are right. Everything else is fixable, or everything else is easily fixable. Facts and dimensions are very hard to fix, because that's like kind of the foundation of your reporting structure. I have some additional resources for you to go through once you go through after this workshop. So you can look at kind of what CDC is, what facts and dimension exactly are. I'm assuming you know basics of that, and warehouse and multi-hop architecture, meaning raw, bronze, silver, gold. I'll pause here for a minute. Do you have any questions with this? We have a question from Levi. In my company, we don't have data models because the analytics like one big table. Yeah, we can create one big table. The problem with one big table is that it's hard to change. It is okay if your company has only one fact, but if you have multiple facts and if you have different metrics across facts, it's going that are the same across facts, it's going to be very difficult to manage one big table. Usually what happens is you create facts and dimensions and then you create one big table from that facts and dimension. That way, you know, you have the best of both worlds. The idea behind facts and dimension is that if modeled properly, meaning if facts are available at the lowest grain, any question, provided you have the data, can be answered from your from the facts and dimensions. You can do that with one big table as well, but then that limits you to one fact. Now, and you might have like one OBT per fact table, which is hard to maintain, you know, especially with refills, and sorry, especially with backfills. Any other questions before we move to the next part? Yeah, data model in silver, pre-joined in gold. Yeah, that makes sense, Levi. That's what typically most companies do. You create, typically companies create OBT if the number of summary tables are large. But if there are like just one or two summary tables, people skip creating OBTs. Lynn asks, what's the design principle for facts and dimension table? That's what we are going to see here, Lynn. If there is one thing you're taking away from this whole workshop, that's this single kind of table. This goes over how to do extract, how to do transform, how to do quality checks, how to do loads, and some optimizations for facts and dimensions. And this should cover about 90% of most use cases. Your skills and your value will come in the transform section, because that's where you implement your business logic. So if there's one thing you're taking away from this workshop, it's this pattern. And throughout the rest of the workshop, we are going to see why each of these matters and what other trade-offs we are making. Any questions? Or let's go to the next section. Okay, so we have two types of tables. You know, there is like dimension tables, fact tables. There can be bridge tables as well, but they are similar to dimensions, so I'm not including them here. But at a high level, facts and dimensions are the main ones. So let's look at fact dimension first. So when we think of fact pipelines, typically these days what you do is you do an incremental extract. So you pull data from the source based on some time range. That's what we do here, you know, based on created at greater than start time, created at less than end time. And then you enrich with new columns. So either you add new columns from the existing data, or you left join some sort of mapping data to create new columns. And then you write to the output. When writing to the output, also called as load, what you do is you overwrite an entire partition. So from extract to transform to load, you are modifying a specific subset of the entire data. Because fact table is so large, you usually work on incremental chunks. Fact tables are usually like TBs in size. So if you think of bronze facts, it's going to be large, so you'll only process one chunk at a time, for example an hour at a time or a day at a time. But typically what happens is you process that through extract, transform, and you overwrite that part in the load. This will ensure that even if you have to rerun, if there are any code issues, if there are any data issues, the rerun will overwrite incorrect data. So there's a question about surrogate key. So the question is, surrogate key is confusing. Is it just creating a new key and adding it to the fact table? So That is what surrogate key is. Basically, dimension. The idea was in a few decades ago, because data processing systems are not as effective and data storage was expensive. What they would do is they would create a specific key column called surrogate key. You can think of it as a incremental ID in the dimension table, and then they will map that to this fact table during enrichment so that the joins can be easier for the MART layer. However, these days you don't need to do that. You can directly join whatever dimension on the dimensions natural key, meaning if you have a customer ID in this fact, you can directly join with dim customer using customer ID. There are some techniques for SED2 type tables, but these days most people don't create surrogate key. These days fact enrichment only happens per fact table. You are not joining dimension table usually. There are some old school companies that still follow that, but that's quite rare. And Levi, if you go to my website and search for SED2 join, there is a way to join with SED2. So let me see here. Oh, there we go. This goes over how you can join fact and SED2 without surrogate keys. In case for normal dimensions, which is full refresh dimensions, you don't need surrogate key. You can just directly join with the ID that will be available in your fact and your dimension. Okay, so let's do an exercise. So go ahead and open this, click on this link. It should open a fact line item table, right? All this does is it extracts line item data and dimension data, right? And then it joins them with left join, which is important. We'll see why. And then it writes them to an output. The load is what writes to the output. What's happening here is if the table doesn't exist, that's what this does. We create the table and partition by month. Excuse me. If it does exist, we overwrite by partition. And this function just ties it all together, and this allows us to enter the start and end time. A couple of notes about the start and end time. Let me close this. One second, it's kind of messy. There we go. A couple of notes about the start and end time. We use start time greater than or equal to end time less than because that gives us non-overlapping intervals. That's what, if you do run one for a day, it gives us non-overlapping intervals. And this is the standard kind of pattern most companies use. You could use something like this, where you say like, hey, pull every data or newest data that are not in the destination, but that will make backfills difficult because now backfills will not be automated. You'll have to manually clean up the destination. So you ideally want to have backfills automated. So that's why we are doing this start and end time. Once you have the code, go ahead and run this command. It should work for fact orders as well. So if you take a look at fact items, all we are doing here is inputting a start and end date. You can just copy paste this in something called factorders.py. Make sure you use orders here. Instead of ship date, use order date, and kind of make the changes here as well. You can just use o.star. Date, you can keep it as this. Instead of ship date, again, you change it to order date. Instead of ship date, you change it to order date and rename this table to fact orders. Once you're done with that, run this command and run this SQL query. It should give you the same number, and I'll see you in 5 minutes. And don't worry if you can't complete it. You have the solutions. The idea is that you just kind of understand how this extract, transform, load process works. And if you have any questions in the meantime, let me know. Yes, Levi, we are not using, we are using Iceberg, so insert override partition should work, so that should be fine. So let's, Lynn asks, what if there are late arriving data in the source table? That's a good question. I'm not covering that exactly here, but that comes with like either you do there are a couple of techniques you can use. We will cover one of those in the dimension section, like how to ensure data is complete, how to capture late arriving data. However, with Fact, there are more techniques you can use, like Lambda. Basically, what that will do is run the pipeline every hour for 1 hour look back, and then every night run it for 24-hour look back to kind of catch all. And that's where this insert override is very helpful, because you can keep on running your pipeline, but the output will not be impacted. You won't have duplicates in the output. So does that answer your question, Lynn? Yes, it's the same key, same partition key if you want. So if you take a look at my website, I go over that technique as well, because it's a little bit more complex than this. But in case you need to handle really late arriving data, you can follow the techniques in this article as well. So look back, it depends on how you want to scale Levi. So what that means is you can run it 1 hour at a time, but typically what companies do is you just run look back 24 hours. So let's look at this example, right? So if you're running Fact line items, so let's say every hour you give the start and end time as 1 hour, but at the end of the day you will give the start and end time as a range of 24 hours. And that's the good thing about having the start and end time as input arguments. It allows us to kind of change the time range from our orchestrator. So Airflow can modify this. You can have like branching operators to do that for you. If we had used this pattern, where we say greater than, that would not work. And that's why I recommend using start and end time as input arguments to the data processing script. I covered this in my Airflow tutorial as well, where you can kind of change the time ranges. So where is that? Yes, override partition works with multiple hours, and that's because we have defined it as such. So if you look at this create part, we are here we are overriding by months, but you can in fact orders, you can override it by, you can create it by hours, you can create it by day, whatever partition you want to use. Any questions so far? Let me know if you are having any difficulty with running these commands. That I can help out as well. Lynn asks, what if the columns get changed in the source table? So there are a couple of things you can do. Again, we don't do schema evolution right now in this because we only have an hour, but there are a couple of options you can do, right? If it's an additive change, meaning if columns are expansive, you're adding new columns, you are changing a smaller column to a larger column. For example, you're changing an integer to a double. Those can be automated, right? If you're deleting, now that's a different different problem, because you can delete and you can automate Iceberg specifically to change schema automatically. Iceberg does change schema automatically, so technically that's not a problem, from the technical aspect of things. However, the problem comes when you think about it from a business perspective. If a column is changing, if something drastic changes, for example, the grain of the table changes, for example, the meaning of the data changes, that is a bigger conversation. You need to be informed upfront about the upcoming changes, or you need to have some sort of data contract with the upstream teams. It's easier when the data team has a good relationship with the upstream teams, but if you don't and they're just throwing changes at you, it's going to be a hard job, because you don't want unintended data schemas affecting your business logic. If it's additive, it's fine because it's not changing anything, but if the meaning of the data changes, it's not easy to automate. You need to kind of have some sort of data contract, kind of like a data contract between your team and the upstream teams. Does that help answer your question, Lynn? Great. Okay. So if you run these two, you should get the same numbers here. We'll wait for that. Right. So up until now, all the logic we saw are pretty straightforward. You know, you join in the examples we take line item join dimension date, we take orders join dimension date, which is great. You can also create new columns from some basic descriptions. There are a couple of things to be aware of here though. Number one, if you are creating a new column, be mindful that you're not encoding business logic. Sorry, I'm gonna stop this because I haven't created the fact order, so that's why it's not opening. But if you go over to notebooks with solutions, it should work. So as I was saying, there are a couple of issues here. One is if you are transforming, if you're creating a new column and that column is somehow encoding business logic, I would strongly recommend you push it to the upstream stream. So let's look at an example. If you're computing discount, that's fine, right? Because you have, you'll have the price, you'll have some discount percentage, so it makes sense. It's a new column. However, it's using existing information. However, if you find yourself changing the discount percentage, for example, based on where the product was sold or based on when the product was sold, now that becomes a business logic. So it's a way of how the business operates. You should typically push these changes upstream. You should not handle them in the warehouse. The idea here is business logic should live in upstream. You are responsible for just getting the data ready for analytics, not applying business changes. It does happen sometimes, but try as much as you can to push your data upstream, because you want kind of the upstream data to be the source of truth. The other part is the transformation we have seen so far are pretty straightforward. You're just joining new columns, left joining dimension mapping tables, right? However, there are certain types of transformations like removing duplicates, identifying related rows, for which you'll need to do like a window function or self joins or even fact and fact joins. So if you, for example, want to identify duplicates, bronze tables may sometimes have duplicates and you might have to do a window function. If you want to do something called sessionization, meaning if I'm logged into a website, I want a group for if Joseph is logged into a website, the data engineer wants to identify all the events that Joseph did. So that's called sessionization, where they assign a unique key per session, login, logout, right? So for those sort of situations, you will need to use a window function. So you are kind of trying to compare row against row. And then there is also like union when you get fact tables from multiple sources. This is usually the case when you're getting, for example, behavior data or geolocation data from multiple vendors. You want to union them. In those cases, it's going to be really messy. I recommend using a standard format. Most of those data sets have a common standard. For example, in ads, open real-time bidding is a common standard. So if you are unioning data from multiple vendors, make sure to understand the standard format before just agreeing to whatever it is that they give you. So let's look at an example, right? Let's say you're tracking clicks and user ID has 2 clicks that happen at the same time. This is almost always the case of like double clicking accidentally, like that. And you don't want to track those as 2 clicks. You usually want to track them as a single click. So you can use something like a row number here, which is what we are doing. Again, comes back to the window function. So there are some cases like this. Depends on your data and your business use case. I'll stop here for 5 minutes. Any questions with fact pipeline? Any other patterns you have seen at work? Anything unclear? I'll pause for like 2 minutes here and let me know in the chat. Oh great, that's basically this code, right? Window function to remove duplicates, row number, yeah. That's great, Levi. Main and as is sessionization done incrementally. Sessionization could, that's a good point, Main. So sessionization, they are usually done incrementally. However, the incremental chunk is usually quite large. So you typically do like a day's worth of incremental processing, and then you sessionize it there. The cross day or cross incremental chunk sessions, they may be dropped in some cases, but it's fine in some cases, but in very, very rare cases, they're not fine. For example, in ads, you do something called attribution, meaning, if a user clicks on an ad and then buys it, then the ad gets paid more. So you want to track that across incremental chunks. So you do something called a look back. So instead of just one day, you will look at the maximum kind of attribution window. Sessionization, sometimes it's fine to drop sessionization or have some duplicates, but when it comes to money, you want to make sure you're covering the sufficient incremental chunk such that even there's no you basically want to make sure you're processing a large enough chunk such that those cases are minimized when it comes to money. When it comes to sessionization, it's usually fine. It's not that big of a deal, but when it comes to money, you want to make sure you capture the whole interval. Does that help, Maiden? That's a great question, by the way. Any other questions? Okay. So I want to make sure that these workshops are helpful. So if you get a chance, please go to this link and let me copy this link and kind of fill out this information. It'll help me make better workshops. And you don't need to I'm not going to reach out to the email as well or anything. That's just a way to make sure I don't get spammed. Okay. So, and if you click on the link in the chat, it should take you to the feedback form here. Okay. So let's go on to the next section. The next part is dimension pipelines. Right. Now, in dimensions, there are full refresh dimensions, SED1 they are called, and then there's SED2. Well, there are about SED7, but most companies use SED1, which is full refresh, or SED2, which is snapshot, which is slowly changing dimension type 2, which has a from and to intervals. I would say for 90% of the use cases, full refresh is the better choice. SED2 is not everyone knows how to use SED2, everyone in the end user side of things, and it's also hard to maintain. So in this specific workshop, you're only covering SED1. I'll cover SED2 separately. If you want to understand SED2, go to my website, click on this thing and look at SED2. That kind of goes over how to create it, what is it, how to join it with facts, and all such stuff. But for this, let's concentrate on full refresh. So what are dimension tables? Dimension tables are denormalized versions of upstream normalized table. What that means is if you have a application database, you will typically have multiple tables representing an entity. So for example, if you have a customer, you may have customer table, customer address, customer credit card, customer preferences. So you might have all these tables in upstream OLTP application system that's optimized for CRUD type operations. However, when we come to the warehouse side, you want to denormalize it, meaning you want to join them all together into one big table because that's easier for analytics. That's basically what denormalization is. And this is what we mean by we join the related upstream tables into a single dimension table. One thing to note there though is that the upstream dimensions usually arrive slower than facts. So that has significant impact on how we design our pipelines. So take a look at dim customer v1, right? Open this Python script. Oops. Take a look at dim customer v1 and dim customer v2. Look at the differences in the transformation types. What are the different, and answer these questions. What would the differences in results be and why does it happen? And if you can choose between v1 and v2, which version would you choose and why? Because they both have pros and cons. Think about the pros and cons from data completeness and fast latency of data, how fast the data is available for end users. Assume the upstream data, which is customer data and market segment. Customer data is refreshed, assume it's refreshed every hour, meaning every hour you had the latest data in there, and market segment is refreshed every 6 hours. For this exercise, assume dim customer v1 and dim customer v2 are refreshed every 2 hours. What would the pros and cons of v1 and v2 be? I'll see you in 10 minutes. And if you have any questions, let me know in the comment section. I see 2 questions already. So the first one is the difficulty is joining data from different vendors because customer ID is different. The second question is, what if entity has a list of things, customer having more than one address? So that's a good question. So let's start with the customer ID different from different vendors, right? So what that means is, you have customer ID from, I don't know, from vendor 1, it'll have like CV1, right? And then customer ID from vendor 2 will have CV2. So the problem here is that you need to create your own key. So what I have done in the past is use something called MD5 hashing. You can use SHA, but usually MD5 is good enough. So what that would mean is, instead of using the ID as, for example, so let's assume customer 1's ID from V1 is CV1, but customer 1's ID from V2 is CV2. Instead of just using the IDs that they give directly, you create your own. What you do is you do MD5 of all customer attributes. So this can be like customer name, customer email, customer phone number, some sort of unique, the set of columns that you think will be unique, that will come out to be like customer 1 MD5. And now if you do the same thing, but for the other source, it should come out to be the same ID if they are the same customer. So the idea here is you identify what these attributes are. You identify what attributes define a customer, and then you do an MD5. Now MD5 will give you the same answer if the inputs are the same. So that should be your ID. Does that help, Levi? So Lynn asks, using MD5, if the underneath customer data changes, the MD5 will also change. Yes, it will change, but that's why I said this should be the customer's unique attributes. So it could be a combination of name, phone number, email address. Again, it's not a perfect science. You have to figure out what combination of customer attributes defines a customer. So that's right, Levi. It's a composite key basically. So if it does change, then the customer is changing. So for example, if email IDs of customer 1 changes from V2 versus V1, there is a change in the customer. So they're conceptually different customers now. So the problem is, why did it not change in V1, right? So that's how you want to think about integrity of data. You want to concentrate on data, not on the source. So if the data changes, then we have to ask the source why it changed. Does that make sense, Lynn? Sorry, there's no easy answer to that underlying change of data, because if the underlying uniqueness changes, the customer is different now. So the other thing Levi asked was, great, what if a customer has multiple links? That's a good question. So one customer can have multiple addresses. So 1-to-M relationships are a little bit tricky, right? There are a couple of ways you can do this. These days, most companies say you have customer ID and then you use address as a struct. So what that would look like is, for example, you can have like customer ID C1. The address would be a list of struct actually. So it'll be like, I don't know, address, zip code, and then there will be a second one. So this is called nested data structure. There are pros and cons to it. Basically, you can, if you store it like this, all the data is in one table. But the con is that you have to explode it if you need to do anything, any analytics with the address data. Or the other option is to have a joining table, so that now becomes a Snowflake table. But that you retain the purity of the customer and address, but now you have two tables. But if you join them, you can use this thing called nested structure. So if you go to my website and you say nested data types, you can kind of see like here, one to many. This is what you are asking for, right? So this is not but basically you have it like this. You have like orders and items, and then you can map it to an array of structs or array of dictionaries, more simply speaking. That's an option, but there are multiple options. You can have it as two tables, but then now we have to join those two tables for any analytics you want to do. Everything, this has its trade-offs too. Does that help, Levi? Okay, I'm gonna assume yes. All right, let's look at the answers. So for answers, again, if you go to Notebooks with Solutions and Workshop, you get the ones with the answers. So let's look at the answers. There we go. Okay, so the problem would be unknown when you're doing joins with customer and market segment arriving in different intervals. You run into this problem called unknown unknowns or known unknowns. So let's say V1, you are doing an inner join between customer and market segment. So if you do an inner join and a data point is not in market segment but it is in customer, so for example C2 has market segment phi, but that hasn't arrived yet in our segment table. If you do an inner join, you're losing that data. No information is available in the output, right? So no one will know that we lost the data. However, if you do a left join, you will know that you lost the data, but you will not know what you lost. So it'll show something like C2, null, because you're doing a left join. So that's the unknown unknown, the first case, if you do an inner join, or known unknown. Second case, you can have null, or you can coalesce that to unknown. The problem is the lateness of data, or sorry, the completeness of data for upstream. So you see customer data arrives every 1 hour. Market segment arrives every 6 hours, but our pipelines run every 2 hours. One thing we could do is run our pipeline every 7 hours. That way, we are kind of sure that the upstream data is complete. That way, we don't have these unknown issues. The problem is that even if we kind of schedule these in like 1 hour, 6 hour, and 7 hour intervals, we are still not sure. We still wouldn't be sure that the upstream is ready, right? Because they are kind of like running on hope almost. You're just saying like, oh, run it 1 hour, run it 6 hour, run it 7 hour. We are just hoping that upstream is ready. There is a better way. With Airflow, with Dagster, they have something called a data asset based trigger, meaning you can say like, hey, for this table, make sure all the inputs have run at least once. So it'll wait for all the inputs to have run and then trigger it. If you go to my website and look for Airflow tutorial, that goes over how to do that as well. So if you go here, so if you go to like database scheduling, yeah, here it is. So with this, you can say like, if the upstreams are, so for example here, asset 1, 2, 3 are inputs, and DAGs will only run if 1, 2, and 3 have run at least one time. So there are like techniques you can use to do this. So that's a question from Levi. If we run every 1 hour and every other 6 hour, the upstream tables, the data is always wrong, right? Only if we make that is correct. Yes. So that is the point of the exercise, Levi. The data is incorrect. Well, I wouldn't say incorrect. Depends on your use case, but you should know that you will be missing. You might be missing data because this is not always the case, right? So sometimes it depends on how the input is generated, but the idea here is you need to make sure that the input is complete. If there's a possibility of incomplete input, you want to make sure that your downstream consumers know. That's the idea. There is no right answer because it's all trade-off. Depends on your use case. End users might be okay with, they might say like, hey, I just need the data as soon as possible. It's okay that I see some unknowns. Just make it available as soon as possible. That might be a use case as well. So the idea is knowing the completeness of input is critical, because if you don't understand that, your output might be missing some rows. So that's the idea. There is no like straight answer. Yes, I do, Levi. It's on my website. If you go to Airflow tutorial, that goes over all this stuff, like how to do like asset-based triggers. Yeah, just go to my website, click on this, and say Airflow tutorial. That's the first one. Yes, data asset revenue. Okay, so that's one. The next question, again, you don't have to execute this, but I've been often asked, hey, why don't we do incremental pipelines for dimensions? You can, but there's a catch. So for this exercise, I want you to go through these, run these two queries. The first query, you do a full extract. This is just a transformation part, so assume you're doing a full extract, transforming the data. You just print it out. In the second query, you're doing an incremental extract and printing it out. Run these two queries, look at the results, tell me what the issue is. I will see you in 10 minutes. And if you have any questions, let me know in the comment section. Are there no questions? You're almost right, Levi. There's in addition to the different data arrival times, there is another issue here as well. So these ones, these are like different. This is not customer and market segment from above. This is like two customer details and customer address. Assume these are arriving at the same time. Then what would the issue be? I will give a hint. Think about the type of join we are doing and the type of data or the range of data we are pulling on the second query. Okay, I think I'll go over the results here. So if you run these two queries, this is what's going to happen. So you will see that you have kind of, yeah, it is that unknown, knowns, and unknown. You're right, Levi. But essentially, this is what's happening, right? You have on the top a customer address table, and on the bottom a customer table. Let's say you are doing incremental pulls, and you pull data updated by 26 January 3rd, right? In the table down here in the bottom, you see you had two customers, C4 and C1, because C1 has had their email updated, right? From the top table, we are only pulling the most recently updated one, so it'll only give C4. Because the C1 from bottom joins to the C1 from top, we are not pulling the C1 at top. So if you do a join, you end up with, as Levi mentioned, an unknown, or known unknown, depending on the type of joins you do. So incremental dimension joins are really complex, specifically because your dimension, you want it to be as complete as possible, and you usually do inner join. Left join is a little bit rare because you don't want to see unknowns in your reporting. You generally do inner join. So it's going to be very messy, and that's one of the reasons I always recommend, as much as possible, doing a full refresh dimension join, because incremental pipelines introduces lots of complexity. So you generally want to stick with full snapshot dimensions because it's just easier to maintain. Backfill there's like no backfill. You just rerun the pipeline. It's just much easier, and it's idempotent as well. That's right, Levi. You just want to make it full as much as possible. Incremental only if the dimension is really large. So that's pretty much the main reason we want to prefer full joins for dimensions, because it's just simpler to maintain. So let's do a quick takeaways. So good design is understanding business logic in depth, what type of logic you want, and then using the right options. Fact is usually incremental extract, enriching with or left joining mapping tables, insert override partition. Dimension pipeline is full extract, full join or inner join, and overriding table. As with most design principle, break them when you need to, but most of the time using this will take you 90% of the way there. So if there's one thing you take away from this course, it should be this table. This will take you most of the way there. We didn't cover quality checks and storage and code, but those are pretty straightforward. Getting the transform, extract, and load setup will be the primary kind of major foundation you want to do. So again, if there's one thing you take away from this workshop, it's this table right here. I'll stay on for a bit for any questions you might have with this or anything data related. Thank you for joining. That's the end. And again, please click on the feedback link in the chat that's pinned in the chat. I would really like to hear your thoughts. It helps me make these better in the limited time that I have. And also there is I'm writing a book on design patterns which covers these sort of situations. So in more depth, of course. So if you want to be a beta reader, please sign up there as well. I'll really appreciate it. Thank you. Levi asks, the quality check with count star. I don't know this because when the job ends, the source has more rows already. That's a good point, Levi. There are a couple of ways you can do this, right? So if you're let me go with the first question, the reconciliation check, right? If the concern here is by the time the output is produced, the input has already changed, so the count star will not match. So there are a couple of options here. One, if you're using Iceberg, you can do something called time travel. Basically, you will say like something like this, right? You will just writing pseudocode, select star from or input where time as of whenever the pipeline started. So that way you know that was the count star when the pipeline started, right? There is a modeling technique you can use as well, where every table will have something called the ETL, inserted at timestamp. So you can say something like ETL inserted at less than pipeline start, sorry, less than or equal to. So that is also an opportunity. But both of these, you need to have either modeling changes, so you need to have an ETL inserted, which will be default now row to the source, or you will need to have Iceberg tables. But that's a good point. That does happen only in like very large scale systems. So I'm assuming you're working with a very larger company would be my guess. Levi says only if you do partition bound joins, the rows don't change. Yeah, if your upstream is not updating, as you say. Yes, that is correct. If you are doing a partition bound job or incremental, it typically doesn't change. Any other questions? Yeah, no. So Levi says, I like dbt tests. It has these kind of uniqueness, not null relationships, and enum belongs to check. I like that too. The problem with the dbt test is that it doesn't follow the standard WAP pattern. So what I mean by that is, for example, let's look at this fact line items, right? Typically what you do is you do extract, you do transform, then you do validate. So here we are not doing it, but extract, transform, validate, and only then load. You don't want to load and validate, because the idea is once the data is loaded into the destination, anyone can access it. So the time between data being loaded, people using it, and then the data quality checks being run, people might have already used that data. So that's why WAP pattern or write, create the table, audit, run the pipeline checks, publish, load into the destination is popular. So that's why I'm not a huge fan of dbt patterns. Now their testing is really good. You got the standard ones with dbt tests. You have dbt expectations, which have way more testing types. So those are really powerful. But then I prefer to have the WAP pattern in there. So there are some techniques you can use with Databricks if you're using Databricks, but just make sure that you test the data before you make it available for end users. You don't want the end users to ever see possibly incorrect data. Lynn asks if there's a networking in your platform for jobs. Do you mean on my website? Maybe. That's a great idea. I do have a pipeline that kind of looks at the jobs on LinkedIn, kind of tracking what's popular. So maybe that's a good idea. Thank you, Lynn. But I don't have it right now. So Levi asks, the WAP pattern we test in silver or write to a marked gold table. Okay. So if you go to my website and you say data quality, where is it? There we go. Should be here somewhere. No, you test before you create the silver table. So let me see. So this is the look at the. I don't know if you can see the image, but the middle part, right? That's the, let's say that's the silver layer. Right, you transform the input, you make sure it passes, only then you write it to the output. There should be a better description of this here. Sorry, I should have I need to make the UX better here, but basically this is the idea, right? So you generate the data, not load it in, you generate the data, you check if it's good, log the results. Only if it's good, you write it to the storage location. Yes, the idea is no one should be able to access possibly incorrect data. So that's the whole idea behind WAP pattern. Levi asks, we shift left, put the responsibility to the upstream source. Yeah, that is a possibility, but most of the issues we see here is that you might do like joins that causes duplicates. You might do filters that are dropping rows. It's mostly to capture the problems that have arisen from our mess. So for example, there are cases where you want to make sure your revenue metrics that you're creating with every run stays kind of consistent. So like outliers should be tracked, things like that. So yes, you can pass along most of it to upstream. However, what happens is when something fails, in the reporting something doesn't look good, you will be the one asked. So you want to make sure you test it. Even if it's upstream issues, you test it before you make it available for end users. So if you do find it's an upstream issue, you can ask the upstream team to implement it on their end. but sometimes it might be issue with your code too. So this is kind of like a catch-all before we make it available for end users. Levi asks, bad data don't even touch our landing raw layer. That is the ideal. You want to make sure upstream data, the data they give you is good, but it's very rare. There's always going to be issues. That's just the nature of the job. We just need to be ready to handle it before it impacts downstream users. Does that make sense, Levi? Yeah, you're welcome, Lynn. Are there any other questions? If not, I'll end it in a minute or so. Please let me know. Yeah, thank you for all the questions, Levi. I really appreciate it. It's very helpful. And if you get the time, please, I'll really love your feedback. Thank you. So there's a question from Manon. I believe this is batch ingestion. That's right, this is batch. For streaming ingestion into key value stores for near real-time use cases, we wouldn't have multi-hop architecture export job from... We wouldn't have multi-hop architecture, but an incremental export job from hot to cold storage for batches. Yeah, that's right. This primarily, this just covers batch pattern, and excuse me. The idea here is, your near real-time ingestion happens in the first layer, the automation and tooling layer. But yeah, that is something that I'm working on right now, kind of understanding micro batching and streaming. I'm working on a post, should be out next week, that'll go over kind of the streaming patterns, because most of the pipelines that data engineers deal with is batch, so I wanted to cover the main ones first. But that's a good point, man, and yeah, for streaming. Oleg asks, will a recording of the session be available? Yeah, this is on YouTube, so my lives will be available. I'll also add it to the newsletter. If you're part of my newsletter in the next broadcast, I'll add the link to it. But essentially, this link, this live will always be available, so you can just it's just on my YouTube. Oh, really? Stream and Kafka? That's interesting. Yeah. Perhaps with like the inference side of things for LLMs and stuff. Yeah, that's a good point. Yeah, as I was telling Main, and I'm doing something on, understanding micro batching and real streaming. So that should help. But Kafka is something I want to cover in the future. Sorry, man, and what's CDP? Is it like consumer data platform or something? Yes, Levi. The one I'm working on right now it uses Flink real-time streaming and Spark micro batch. Spark streaming real-time mode is out. It's generally available, but it doesn't do stateful transformation, so it doesn't do like window functions or things like that just yet. So I'm focusing on kind of comparing micro batch using Spark streaming and real streaming with Apache Flink. Yeah, Flink is great. I used to use Flink when I had to do the streaming pipelines, but yeah, it's Spark 4.0. I don't remember exactly, was it 4.1 or 4.0, but that was generally available a few months ago, if I'm not mistaken. The Spark real time mode. I don't know about that, Levi. I'm not sure the Flink is that, like, streaming is that hot right now. I feel like from what I'm seeing in the industry and interviews and people looking for jobs, it's mostly just batch, micro batch sometimes, with Spark streaming, but that's extremely rare. I worked at a couple of companies where we actually had streaming systems but moved away from it just because the complexity of it kind of grows exponentially. It's hard to rerun, it's hard to do backfills. It's a lot of, you have to think about a lot of edge cases with streaming as well. So I'm seeing more of like either micro batching or just batch pipelines running every hour, every 30 minutes, more so than streaming. But yeah, something I want to cover for sure. Levi, is that in the U.S. market, or where are you seeing this? If you don't mind me asking. Got it. Got it. Main, I'm not sure if Flink alone is sufficient. Yeah, I don't think Flink is sufficient for analytics. It's so these streaming pipelines that are usually, from what I'm saying, they're heavily scrutinized. So it's like only if you absolutely need it. So things like credit balance, uh, ads attribution. So what that means is you have like real-time bidding running on ads. So when you click on a link, there's a bidding that happens immediately, and you get redirected to the winner. That processing, updating budgets and such, they are usually done with like near real-time processing. But then once that's done, you still need the batch structure to handle the rest for you. And when it comes to Lambda architecture, man, and I've seen Lambda in like batch pipelines as well. So what I was talking about earlier with like running the incremental pipeline 1 hour and then 24 hours at the end of the day, it's kind of a Lambda architecture. You're running fast layer 1 hour and slow layer 24 hours. So I've seen that in batch as well. I've never seen like batch and streaming as part of the same pipeline. So industry specific pipelines are deep dives are a little bit harder. I mean, because the data is not there. I mean, I can go over ads or finance, the ones I'm familiar with, but the data is very rough to get because ads is like there are so many differences depending on the companies, but yeah, the standard ones, that should be doable. That's a good idea, Lynn. Thank you. Levi says, I work for government and project for security. Wow, that's intense. Yeah, that makes sense. Yeah, I don't. Yeah, I see why you would want streaming there. Yeah. Wow, that's some intense project, Levi. Yeah. Yeah, I hope this was helpful, and please email me at joseph.machado@startdataengineering.com, or kind of go to the about and reach out through here, or LinkedIn. I typically get back as soon as I can. Don't do. That's probably a good idea, Levi. It's. I feel like that those sort of calls will be too rough to manage. Yeah, sorry to hear that. Yeah, as I was saying, just reach out anytime. Happy to help. And yeah, I'll see you all in the next one. Thanks, everyone. Bye. Sessionization? Sure, yeah. Sessionization is, I can cover that, yep. That's a good point, yep. And please, if you're running it on GitHub Codespaces, please don't forget to turn it off, because it might be quite expensive if you forget to turn it off. It does automatically stop it, but just make sure you stop it. Alright, I think we are quite over time, and I'll thanks everyone for joining again. I'll see you all next time.